Итак, сейчас Иван Фролков.
So now Ivan Frolkov is going to tell us about the isolation of transactions. So, okay, everyone has come, or we should give them another minute or two to come. So, do we wait or do we start? Okay, let's start. My name is Ivan Frolkov. I work for the Postgres professional company, and what I do there is I'm supporting the developers of the applications. I'm going to tell you about a widely known, but not everyone understands it well. What I mean is the transactions isolation and why did I come to this interesting conclusion. I have to talk a lot to candidates, I have to interview potential employees, and among other questions, I usually ask them, do you know what transactions isolation is? Who of you know what transactions isolation is? Okay, quite a lot of people here, but everyone should know what transactions isolation is, but only 50% knows about it, is aware about it. But from the people who come to us, usually more than half knows what that is, but mostly their information, their knowledge about it, they just say we know what the isolation is, and then they just can list it, can say what are those. And that's a strange thing because transactions isolation defines how the transaction interact with each other, because they can be run in parallel, and it's a good thing to know actually. On the other hand, we can also think why people don't really know or have superficial knowledge about such an important issue. It's probably a rhetorical question, but practical too. I will touch upon this question at the end of my presentation. An important thing that not a lot of people know about, and why is that? Small technical issue that now it's solved. Standard levels of isolation, there are 4 of them, and usually people are able to name them. So, reading committed, read committed, and repeatable read and serializable regarding the serial transactions. And a lot of people, after that, not even a lot of people, quite often people can, without a lot of understanding of what is going on, they can say, they can describe each of these levels, peculiarities of each of these levels, and how do they manifest. Usually they describe it by some phenomena. For example, read uncommitted, you can see uncommitted transactions and the changes that happened there. Read committed, we can only see the committed transaction. Repeatable read is that we read the line one time and then it will be read in the same way. It's not going to change. It's an interesting error. I will draw your attention where we can find it at the level of read committed. Some unpleasant things happening there, and serializable at the complete illusion of the serial execution. And I might be mistaken, a couple of years ago the Postgres was the only place where you could find it, maybe repeatable read and serializable levels. So in between them there is isolation snapshot. It's not standard, but it is implemented in all the bases, so the difference might seem minimal, but that's not completely true. So where does it come from? If we consider the levels of isolation from the other side, how it was done some time ago, then everything is becoming really transparent and understandable. When I started working, I had a book on SpanDiaz that was published in the Soviet Union. A really good book, actually, interesting reading, and it was a good book for 1983. Apart from SQL, and other things, they didn't have other bases. There was Oracle. I don't know how it looked in 1983 because it was released only in 1979. Probably it wasn't really in good conditions. So that book was about how all these things were executed and run in those bases. So we had servers, not really servers, more like databases. They had strict blockers, and now strict DB2. We had some Russian Railways people here. Oh yes, here you are. DB2 is a blocker now too. Is that true? Yes, they are nodding their heads. So traditionally it is considered a blocker. So Oracle is a version software. We considered how it all works with blockings, so we can see how it's done, because they were creating standards back then, so it stayed on since then, even though it doesn't really correspond to the actual modern realities. First of all, we must say that in any database, all the blockings that it's taking for the variable lines, deletable, renewable, or insertable, they are going to stay there until the end of the transaction. Before I prepared to this report, I was just browsing online to see what people are saying about this isolation. I found a large website, and it said that the blocks for the changes are lifted after the end of the query, not after the transaction is over. But now all the blocks that are created, they leave until the end of the transaction. So all the blocks that they can put in manually, they also stay on until the end of the transaction. So these are inclusive blocks. We also have visible blocks. If you look at this table, it will be clear how it was done. At the read and committed, we just ignore anything else. We can read whatever we want. Read committed, we read whatever is not blocked. In repeatable read, we are adding a block for each line. We divide them between lines, and it's realizable. We just block it all because there are no actually other ways. And if we look at this that way, then it all makes sense. How it was done, we ignore someone else's for reading, and we read someone else's blocks, and if we don't ignore them, then read committed is going to work really slow. If the operation is not large, then it's no problem, but when there are a lot of operations, then the productivity goes down, performance goes down, and in the interactive applications, it could really improve performance. In Postgres, the level of isolation, read and committed, they don't exist because it's not giving any advantage, so there is no use to have anything like that. So we go on read committed in Postgres level is by default. The isolation level can be set, configured in the server by default. If you don't do anything about it, it will be read committed. You can put it higher, and the driver for someone I don't really remember. Okay, I'm not going to deceive you. So there was repeatable read. If there is the chance, you should really use repeatable read, and I will tell you why. It's realizable, but you should be really careful. But I guess that's really the best way to go. That's the table that I stole from one of the manual, the levels of the isolation. And it's described here in this phenomenon, the repeatable read. So what is a phantom? If during the transaction some other line is added and we read the same query, and out of nowhere we get this new line. So if you are making a report, it could really get in the way. New lines in the reports could be a problem in the snapshot isolation that is repeatable read in Postgres, but I will talk about it later. And there you can actually stumble a lot. You can make a lot of mistakes with that. A small page just for your information how it looks in Postgres. If you don't know, for each line we have two hidden columns. You can see it. If you are using xmin, xmin is the transaction that created the line, xmax is the transaction that deleted the line or that isolated the line, or it is an isolation. So what is isolation or the transaction? You can find that out using the special structure of data that is called CLOG. If you look at the Postgres catalog, so it exists there, so there is a node for everything, what's doing what. So if it's transaction or something else, we have an ID of transaction that are being run. You can get these functions. Well, I don't know how to read it. Third from above. There is also fourth function that is returning the current snapshot, is when the transaction has started. And you can see how it should be looking. The transactions are being run at the moment, so you can show there how it should be managed. And another parameter which is important for serializable, max spread logs per transaction. I don't know how it's actually read aloud, so it is for predicative logs per transaction. If you're going to work with serializable, please pay attention to this. It's an important thing because with the small values, you can have certain problems with because this transaction will fail, will give you errors. So how is it all implemented? All these isolation levels in Postgres uncommitted doesn't exist in Postgres read committed is by default snapshot is taken for each query. So your query sees a static base, but that's not really true. The queries that commensable expressions in everything sees their own base, so you should be really careful doing this with your upgrades of your lines for the queries. So you should be really careful if it's being run in parallel. Repeatable read is actually a snapshot for the entire transaction, not for one query, as it is in read uncommitted. So the workload for the server is the same, but it's more convenient because it allows you to avoid not a mistake, but one feature, one peculiarity. And Postgres could be proud of serializable, and Postgres is a true thing, real thing, and it doesn't allow for problems to exist, the problems that snapshot isolation could give you. I will show you later what kind of problems we could face, and it's a dangerous thing because you can really hurt yourself doing that. And as I've said before, since the majority, most people can't really say what the isolation levels are, probably they never faced any problems with that. And it's interesting questions. Why didn't they have any problems with this? Actually, they had. First of all, the most of problems they just go unnoticed. A lot of problems, they say it was just some glitch, some general things, so something went wrong, so it's okay, or user is stupid, one of the options, or someone got broken, but it never happened again, so I don't know what happened. And some mistakes, some errors, they just go unnoticed, remain unnoticed. It can go on for years. Maybe people won't notice them ever, or maybe if there's audit, financial thing, and they will have to say where money are gone. And partially, the reason is that a lot of applications are interactive, and each user is working with their part of database, and they don't cross each other. So that's why there are no problems because of that. And we had some clients, one large retailer, they had a loyalty program. I don't know, maybe they are here? Do we have this retailer here? The people that came at night back then. So, okay, if they're not here, no one will be offended by this example that I will give you. So they achieved that every user with these loyalty cards, with the discount card, they could block each other. So it can really happen differently, but mostly they created problems for themselves, but nevertheless, the problem is what I suspect that not everything went well, so I guess these bonus points were leaking away somewhere. I haven't installed an application to see how it works. Does it work? So if it's not working, okay, great, now I know the reason. So when I was counting, okay, my bonus points are okay, but I haven't been doing this for a long time, but on a number of occasions it seemed to work well. So it is really a good thing to know what our isolations levels are and to know what problems it could cause. And the main idea of this presentation, so in red, the database is not just some simple storage, but that's also a tool to synchronize business processes because it manages the actions of business agents so they didn't cross each other's paths. In Postgres, this realizable level was created by the Wisconsin police officers. So what is their dark secret? Why they needed that to do this serious thing? So maybe they took someone's car or they wanted to put a person in prison for the second time. So something happened that they needed a separate level of isolation to work with. So they just needed a separate serializable and database, and it's an easier way than to rewrite the code that already exists. Some people could say that no, we don't need this, we're smart enough, we can do it manually and everything is going to work well. Maybe, but I have my doubts. And then I will give you some examples of the errors that you could face. The typical thing is a comment for the post. We add a comment to the post, and when we add it, we have an error. We see an error because the transaction started, some other transaction deleted the post. We're trying to add a comment, and then we see an error. And it's a good thing to see error if we a problem with foreign key. I had mentioned a year ago, I think, or a year and a half ago, about one organization. We had a contract with them, and we needed to work with foreign key to implement foreign key to their tables. They had a pretty old database. The organization was pretty large and serious. Well, okay, they're a bigger organization, but that one was quite large, so like yours. But it weren't yours, not Russian Railways. And a foreign key, we didn't manage to implement it to their table because unfortunately they had some weird lines. No one knew where it came from and no one knew what to do with those. And then I had the question, if you don't know what to do with these lines because they're suspicious, do we really trust those lines that are not suspicious looking? So what can we do? In this case, how can we avoid it? We can block the post or we can put an isolation level in it. What kind of isolation level? Well, I guess we can put the higher than red committed, plays repeatable read. So if we read the post, we could read it the next time. Yes, there will be some special things about it, and you will need to remember this. And the second example of what can we do? A unique thing on the red committed level. So you can't really do it manually, or you serialize it all using an separate isolation, or you won't be able to do it because there will be some double payments if you are doing tens of thousands of these payments and small payments. So a lot of time will pass before you will notice that some money disappeared, and maybe you did it on purpose. So these things can be really unpleasant for a developer. How can we avoid it? We can use a unique key to generate unique key. I really recommend to do that, so you could refer to that. So that's the payment, that's the key of the payment. Or we can isolate a certain client, one line per client. Or we can put a certain level of isolation. What level of isolation? Unfortunately, level of isolation will be serializable because we might face some problems. And another great mistake, I'm not going to read it. If you look with attention at that, so try to find what's the problem here. We are renewing the line with two transactions, where it might seem that one line should update, but that's not what happens. So here it goes. So just see in red letters what's the problem. I don't want to read it aloud because I don't really like to have a karaoke presentations, so to say. When we are renewing the lines, so it getting reread again and nothing gets renewed, nothing gets updated, as if nothing ever happened. I will just talk about other stuff a little bit now. We had some clients that took them a year to face this hybrid transaction, and they always face this problem, so they use the option to kill it in an hour, and they still have it, and they are sitting in this chat room and Telegram. I'm just looking at them talking about this. Well, okay, if you are fighting with this idling transaction for a year or more, then what is happening with this kind of stuff? What is going on in your database? How can you really trust it? Does it really work properly? Well, it's still an open question, an open issue for them. They haven't managed to beat idle transactions still. I don't know what happened next. At the level of repeatable read, there can be some mistakes. So we have a table, we get the sum of all lines in this table, and we add. So we have two transactions running straight. That's the result we get, and they wouldn't give the result if it was run consequentially. And it should show that it's done this way, but it's not working, so you won't get the result you need.
Another example of repeatable read errors. So we have two groups of strings. One is black, another one is white. We have two transactions that are being converted between black and white. And depending on this situation, we may have three results. It's either everything is black, it's either everything is white, or it's black and white. So I don't know it happens if you are using a complicated logics. It's something more complicated, more sophisticated, I would say, and it happens just when everything seems to be normal, and it actually can be quite suffering. So another example, and it's all about like tables with orders, and we add batch orders. We have a batch counter, it is incremented by 1, and then we calculate the sum. Under certain conditions, we can. So it can be one order or several orders that were included into a batch, and it is to be noted that you are not likely to test it. It can happen rarely, like once in a few days, or once in a month, or once in a year. And the task of the database to be a synchronizer of business processes in the organization fails, because if you get a report, you can see that like 100 units were loaded from the warehouse, and you have only 90 in your report. Where you have the rest 10, it's okay when it's just 10, not a million. And what can you do in this situation? You have to be quite careful. What can we do with this? How we can tackle this problem? So first, you can use isolation level, which is serializable. How is it implemented? You put special lock on red strings, you keep the transaction, and with these strings, if there are any conflicts, you get an error like there was a conflict, and let's roll back. You can't do anything with the transaction. All you can do is to roll back and to start it over. Just yesterday I was watching TV. How to say? So one of Moscow institutions, municipal institutions, said our doors are open, everything for our customers, and it's good. But back in the days, when I asked them how are you working with deadlocks? What kind of deadlocks? We don't have any deadlocks. I don't know how it is organized right now, and maybe they fixed it, but back in the days, they were not able to process deadlocks, but deadlocks happen always. And you must be ready to process deadlocks and serialization errors. It starts with 40001 value in SQL state. In our multi-master, serializable error will be the same. So you have to process not only deadlocks, but you have to be ready to start the transaction over and to fix any problems. So just like with deadlocks, you have to be ready that you cannot call any external services, because deadlocks can occur several times. It can be quite unpleasant, and if you need to build a report in Postgres, you can use read-only isolation level. It will wait for the moment when it can get a real log and do everything correctly. It will wait for sure, and it will run. With the serializable level, there are certain serious problems, meaning it demands several resources, and if Postgres sees that there are a lot of logs on a page or on a string, it will promote it, and then it can actually drop the table. If you change something very intensively, your performance can be degraded, and unfortunately it doesn't happen. And what can be done in this situation? For all important serious tables that you would need, I recommend you to have to use a serializable isolation level. You can use trigger for it. For example, if the system sees that the isolation level is different, it will send you an error, and you can give permissions only for procedures execution. This is the only option. If you do it manually, well, you have to be ready that someone else can come over and then just use logs manually for update, for shared. Dmitry Vasiliev, who was speaking in front of you just before me, I had a chat with him. If you are using for update log, which is quite good and interesting, but it's more heavy. It's heavier than advisory log. He implements them in millions, and he sees some performance gain. It's not that I'm recommending you to use it, but it can be quite helpful for you someday. So that's it from my side. Should you have any questions, I welcome them. Thank you. And where is the mic? There were 2 mics in the room. Hello. Hello. Tell me please, what criteria Postgres uses to scale up logs from individual strings to the whole page? It is called logs escalation. It happens only when serializable log isolation level is used. Otherwise, it will not be triggered. So you have to take a look at your code. For example, if half of the page is full, yeah, it will trigger this isolation level. So it will log half of the page and then it will switch over. Yep, this is the case. What about from one page to the entire table? How many pages should be logged? It depends on marks per log per transaction parameter. So I showed you at the beginning. Let me find it. So this one, max spread logs per transaction, the last one. So everything depends on this parameter, exactly. So as a polyadditive, you don't have to put all operations into serializable, but just the most important ones, like money, like legal affairs, something like that, in order to avoid serious problems. The rest can be processed in a different way. If you just put something into databases and this information is not that important, let it go. So I asked this question to Bruce. So in order to serialize access to a resource, we use select for update. In Oracle, from which I migrated, you can indicate the number of seconds of timeout. If the queue is too long, it gets bad. In Postgres, I can only say no wait or to wait forever. Is there any bypass, and are you planning to use a timeout? Are you going to implement timeout? As far as I know, there are no such plans. I would use no wait, but I would fall asleep, but it's not a good idea. But because if you're using something interactive, it would be a bad option. So you have to be used not only to process serializable, but deadlocks only also. But I don't like this idea because the queue will be too long. Well, what if we just organize a queue? Any more questions? Hello. Thank you very much for your talk. It was very good to listen to you and to Bruce. I just wanted to ask you about the following things. What would you recommend, what architectural solutions would you recommend to avoid such situations? I see that you can use one table several times, may leave the log, and so on. Apart from microservice architecture, are there any other options, and what option and what literature would you recommend to get deeper into this topic? Well, I don't know. Conflicts. I am afraid that I would recommend you to read something about blockchain. There is something about conflict resolution, especially in distributed environments. Unfortunately, there is no versatile or all like a universal recipe. Maybe it exists, but I don't know it yet. I'm here. Hello. Tell me, please, when transaction starts, it is serializable. I want to launch it. There are no locks at the beginning, so Postgres cannot calculate. It cannot look forward what kind of locks can be triggered. No, it doesn't know. Maybe in time. Yeah, it's just in the course, in due course, as your application works. So it's all about so the client may not be aware of the tables. So maybe if the transaction can change the information before the lock is triggered. Yes, if you have run a transaction, this is the case. But can I lock a part of the table manually? You have select for update, for instance, and select for share, and you lock those strings easily. You can do it just for sure. Are there any locks for the entire database? You can use lock table, you can lock the whole table. But I don't know whether it's useful. Thank you very much for your talk. I have a question. You mentioned that with a read commit isolation level, it is possible when you are checking a complicated solution, the check will be unexpected. Is it possible in Postgres? You mean a recheck? So Postgres tries to lock a string. It is locked. It waits until it is released. It reads it once again, and then it checks the condition. Anything wrong with it? Oh. Can you show us the slide? This one? So I was suggested to talk about this offline. Just we prepare the room for the next speaker. I want to give you a comment about logs and how they're organized. In fact, serializable. Everything that Postgres touched will be marked by Postgres. So other serializable will know about it. If it didn't change, it can add its own lock. So not to lose it. But if serializable touched something, so the second serializable will wait until it becomes untouched. And another detail, serializable lock is not very good compatible. Why we say that you have to work with important things, because serializable can conflict with read committed, but at different levels, so it doesn't see them. And you have to take this into account. If you touch accounts in serializable, do not touch them in parallel commit.